Do you want to know how to prepare data coming from observables before it reaches the subscribers in RxSwift? Let's check out the 3 most common transforming operators you need to know about. In the last video we looked at various filtering operators to be familiar with to get closer to becoming an RxSwift rockstar. This time we will cover perhaps the most important type of operators you will be working with, which is the transforming operators. The transforming operators are used to model the data emitted by observables to meet the requirements of the subscribers. RxSwift offers a wide range of operators that provide control over data and events in your application. We will only be focusing on the most commonly used operators. And the first operator on the list is one you will likely be using the most. It's the map operator. It works similar to the standard map operator from Swift, except it works on observables. Here's what you can do with it. The map operator lets you apply a function to each element emitted by an observable. The operator will then return an observable that emits the results of the function. It looks like this on a marble diagram. In this diagram, the observable sequence containing the values 1, 2 and 3 is passed through the map operator that will multiply each value by 10. It then returns an observable sequence 10, 20 and 30. Let's put this operator into action in code.
So first off we will make the observable, and then we apply the map operator to multiply each value by 10. We subscribe to the next event and print out the result. And here we see the values 10, 20 and 30.
It is possible for an observable sequence to contain observables that you can subscribe to. In that case, the flatMap operator is a lifesaver to reach into each element of a sequence and deal with the inner observable sequence that may be contained in the elements. In this marble diagram, the input on the upper line is an observable sequence containing observables represented with circles. If we look at the output on the lower line, the elements emitted by the input observables are collected in a single observable sequence. In other words, the flatMap operator removes the multiple levels of nested observables and instead flattens them into a single observable sequence. Much easier to work with. Now that we got the flattening part down, I'll remind you that the operator contains map in its name because it's also possible to apply a function just like the map operator from earlier. This is similar to the map operator but looks slightly different in code. Let's check it out.
Now in this example we have the struct person containing the behavior subject car. Now we create a published subject of type person. On this published subject we will apply the flatMap operator to extract the car from each person. We then subscribe to the next event to print out each car. Now we will create different persons. And add them to our published subject. Notice how the flatMap operator monitors for changes on each observable at once, as seen when John gets a new car which is printed.
Now let's look at flatMapLatest. As the name suggests, the flatMapLatest operator shares many similarities with the flatMap operator. The difference between them is that flatMapLatest only produces elements from the most recent observable. This means that flatMapLatest switches its monitoring to the newest observable and ignores emissions from previous observables. Let's see this in action using the previous example.
We change the flatMap operator to the flatMapLatest operator, and now we see that the update regarding John's new car is never printed because John is no longer the latest observable. Instead, Alice is the latest observable.
Thank you guys for watching. If you liked the video, leave a like. Make sure to subscribe and check out the previous video in this series on RxSwift, and stay tuned for the next one.